The second part in this section, we are going to talk about the atmospheric pressure. The atmospheric pressure is the pressure of the atmosphere on the surface of the Earth. The atmosphere is the shell of air surrounding Earth, which exerts pressure on the surface of the Earth. The gas molecules surrounding the surface of the Earth are colliding with the surface of the Earth. So they are exerting pressure on the surface of the Earth. So it's called atmospheric pressure. So atmospheric pressure is caused by the weight of gases that compose the atmosphere. At the surface of the Earth, all of these molecules contribute to the pressure, but as we go up to a higher altitude, only these gas molecules contribute to the pressure. So at higher altitudes, the atmospheric pressure decreases. And as we all know that the atmosphere is not consisting of only one type of gases, it consists of different types of gases. So the atmospheric pressure will be the sum of the individual pressure of the various gases. But how we can measure pressure? We measure pressure by a device called a barometer. A barometer is a device used to measure atmospheric pressure. And the first scientist to introduce the barometer was the Italian scientist Torricelli. And this is the barometer. The barometer device consists of a glass tube filled with mercury and a glass dish also filled with mercury. How it works? At first, Torricelli filled a glass tube with mercury. Filled the glass tube to the very end with mercury. Okay, and he then closed the open end of the tube with his thumb, preventing any air molecules to enter inside the glass tube. He then inverted the glass tube into the dish of mercury without allowing any air to enter the tube, and he opened the glass tube. He found that the mercury is dropping to a certain height, which is 760 millimeters of mercury. What makes the mercury drops? The force of gravity. The force of gravity pulls the mercury down. So it drops to a certain height, which was 760 millimeters. But why the mercury stops at this height? Why 760 millimeters? Let's go back a little. Scientists back then did an experiment, but using water. They brought a long glass tube and they filled it with water. And they also brought a dish and they filled it with water. Then they closed the tube and inverted into the dish. And they opened the tube and they found that the water is dropping to a certain height. But in case of water, it drops to 10.3 meters. They didn't know why the water is stopping at this point. Why 10.3? Why there is a vacuum inside the tube? Then it came Torricelli. Torricelli thinks about why water is dropping to a certain height. Why this height? Why 10.3? He thought that the water in the dish is exposed to the air, and the air molecules are exerting pressure on the surface of the water. So it pushes the water up inside the tube. So now we have two pressures. The pressure of the air on the surface of the water, which pushes the water up. And the second pressure is the pressure of the water inside the tube by the force of gravity, which pushes it down. So when the two pressures are equal, the water is dropping until the two pressures will be equal. The atmospheric pressure, the first pressure, and the second pressure is the water pressure. The water will be dropping until the two pressures are equal. And then the water stops at 10.3. He then replaced the water by mercury and did the experiment again. He found that the mercury are stopping at a certain height, which was 76 centimeter or 760 millimeter. And now let's talk about the units used to measure pressure. There are a lot of units used to measure pressure. The first unit to measure pressure is millimeter of mercury, which has the symbol mmHg, millimeter of mercury. And the millimeter of mercury is also called torr, in honor of Torricelli for his invention of barometer. So, millimeter of mercury or torr. And another unit to measure the pressure is the atmospheric pressure, which we give it a symbol of ATM. So the first relation is 1 ATM, 1 atmospheric pressure, will equal to 760 millimeter of mercury and also equal to 762. Another unit to measure the pressure is the Pascal, which has the symbol PA. So 1 atmospheric pressure will equal to 1.01325 times 10 power 5 Pascal and equal to 101.325 kilopascal. The last unit to measure pressure is Newton per centimeter square, and the 1 atmospheric pressure, 1 atm, will equal to 10.1 Newton per centimeter square. And we have to memorize all of these units so we can convert from one unit to another unit very easily. So 1 atmospheric pressure, 1 atm, will equal to 760 millimeter of mercury and 762. 1 atmospheric pressure will equal to 1.01325 times 10 power 5 Pascal and will equal to 101.325 kilopascal. And also 1 atm will equal 10.1 Newton per centimeter square. Let's solve a problem about the conversion between units of pressure. The average atmospheric pressure in Denver, Colorado is 0.830 atm atmospheric pressure. Express this pressure in millimeter of mercury and kilopascal. How we are going to solve this problem? The first one, he wants to convert between atm to millimeter of mercury. Okay, let's write the numbers we memorized. That 1 atm equal 760 millimeter of mercury. And he gave us the pressure in atm. So 0.830 atm will equal how many millimeter of mercury? We just are going to do a cross multiply. So 0.830 atm times 760 over 1. And it will give us 631 millimeter of mercury. The second one, he wants to convert between atm to kilopascal. So we will write the numbers we memorized. 1 atm equal 101.325 kilopascal. And 0.830 atm will equal how many kilopascals? Another cross multiply. 0.830 atm times 101.325 kilopascal over 1 and will give us 84.1 kilopascal. Now we are going to talk about something called Dalton's law of partial pressure. Dalton is a scientist who studied pressures of gases. Let's consider we have two containers. Container 1 contains oxygen gas, and the oxygen molecules inside the container are colliding with the container walls, exerting pressure on the container walls. So the pressure of oxygen will equal to 159 millimeter of mercury. And we have a container 2. Container 2 contains nitrogen gas, and the nitrogen molecules inside the container are colliding with the container walls. So they are exerting pressure on the container wall. So the pressure of nitrogen inside the container will equal to 593 millimeter of mercury. Then we are going to have a container 3. Container 3, we are going to put both oxygen and nitrogen inside the same container. So they are colliding with each other and colliding with the container walls. So the pressure in this case will equal to the pressure of the first gas, which is oxygen, plus the pressure of the second gas, which is nitrogen. So the total pressure in this container will equal to the pressure of the oxygen, which was 159 millimeter of mercury, plus the pressure of nitrogen gas, which was 593 millimeter of mercury. So the total pressure will equal to 752 millimeter of mercury. Now we have a mixture of gases. So the pressure of oxygen, only oxygen in this mixture, is called partial pressure. And the pressure of nitrogen in this mixture is called partial pressure. So what is partial pressure? Partial pressure is the pressure of each gas in a mixture is called partial pressure. So Dalton's law of partial pressure states that the total pressure of a gas mixture is the sum of the partial pressures of the component gases. So P total will equal to P1, the pressure of the first gas, plus P2, the pressure of the second gas, plus P3, the pressure of the third gas, plus and so on. So if the container contains more than one gas, the total pressure will equal to the sum of these gases. Pt is the total pressure of the mixture, and P1, P2, P3, and so on are the partial pressure of the component gas. Now we are going to talk about another form of gases pressure, the pressure of gases collected by water displacement. What is the meaning of gases collected by water displacement? The gases produced in the laboratory are often collected over water. Like this. Here, we have a reaction that is producing gas, and we want to collect this gas. So we are going to connect it by a tube to a dish filled with water and a test tube. The gases produced in this reaction will travel through this tube and forms gas bubbles in the water, which will rise in the test tube, and the gas will be collected over water in here, in the test tube in here. But as the gas bubbles is traveling through the water, some of the water molecules at the surface of the water will evaporate and mix with the gas molecules. So water molecules at the liquid surface will evaporate and mix with the gas molecules. So now we have here two types of molecules: the molecules of the gas collected and the molecules of the water evaporates. So the total pressure inside here will equal to, yes, the pressure of the water, which is called vapor pressure, and the pressure of the gas. So the total pressure, or the atmospheric pressure will equal to the pressure of the gas collected over water and the pressure of the water itself, the vapor pressure of water. So now we have a problem. Oxygen gas from the decomposition of potassium chlorate KClO3 was collected by water displacement. The barometer pressure and the temperature during the experiment were 731 torr, this is the atmospheric pressure, and 20 degrees Celsius. The vapor pressure is 17.5 torr. This is the water pressure, the vapor pressure. Vapor, water vapor, the vapor pressure. So this is the pressure of water. What is the partial pressure of the oxygen collected? So now we have given the atmospheric pressure, which was 731 torr, and the vapor pressure, which is the water pressure, and it's equal 17.5 torr. And the relation, the atmospheric pressure equal the pressure of the gas, and in this case it's oxygen, so the pressure of oxygen plus the pressure of the water, the vapor pressure of water. And he asked about the pressure of the gas. So the pressure of the gas will equal the atmospheric pressure minus the vapor pressure, like this. 731 torr minus 17.5 torr, and it will equal 713.5 torr.